Hello everyone, I'm Aniket and today is my first lecture on multiplexers. Multiplexers come under the combinational logic circuit. So let's move and understand what is combinational logic circuit. So combinational logic circuit is formed by combining different logical circuits. When different logical circuits are being combined and form one circuit, it's known as a combinational logic circuit. In the simple terms, we can say it in this way. These combinational logic circuits are available in the form of ICs. ICs is known as an integrated circuit. These ICs has nowadays are being getting reduced in the size. Because of that, the cost of the system is getting reduced. So the examples of combinational logic circuits are multiplexers and demultiplexers. These are the basic examples. So now let's move ahead and understand what is multiplexer. So multiplexer is a device which has multiple inputs and single output. These multiple inputs are available on this side as you can see here 1, 2, 3 up to n. And out of these n inputs, only one output is being selected based on the select lines. The select lines are also known as the control lines. Okay, so let's understand this block diagram in detail more. What's the n is been representing? N is the number of input lines. N is the number of input lines. Now what is m? M is the number of control lines. M is the number of control lines or a select line. And Y is the output. Okay. So now there are many type of multiplexers are there like 2 is to 1, 4 is to 1, 8 is to 1, 16 is to 1. So this what this terms 2 is to 1, 4 is to 1 is representing. 2 is to 1 means two inputs are there and only one output will be there. What's the 4 is to 1 then? 4 is to 1 is four inputs are there and one output will be there. In the same way 8 is to 1 means 8 inputs will be there and one output will be there. So this 8 is to 1, 16 is to 1, these all are available in the form of 2 power. Okay, now how to select this select lines, how to find the number of select lines will be available. For 2 is to 1 it is one select line is there. For 4 is to 1 two select lines are there. So how to find, how I am getting that there should be one select line or two select line? So there is a formula or we can say a relation between n and m is available. You can see here 2 the power m is equal to n. When it has been said I want a multiplexer 4 is to 1, so n is 4, so 2 power m is equal to 4. So 2 power 2, we know 2 square is equal to 4, so m value becomes 2. So number of select lines will be 2 select lines will be there. Now let's say I want a multiplexer 8 is to 1, so n will become 8 here, n will become 8. So 2 power 3, we know that 2 cube is equal to 8, so m value is becoming 3. So here 3 select lines will be there. So we are getting now how this block diagram is being made, how 2 is to 1, 4 is to 1, 8 is to 1, 16 is to 1 block diagrams will be made and how we are selecting these select lines. Okay, now let's move ahead and understand the logic diagram of multiplexer 4 is to 1. So here is the logic diagram of 4 is to 1 multiplexer with the truth table is also available. So now let's understand about these terms. This capital A and B are the select lines. See here I have written A and B are control lines as well as select lines. Both are same. This D0, D1, D2, D3 are the input lines. These are the input lines, and y is then output. So here is the truth table. So based on the truth table, I will be explaining you this logic diagram. These are the AND gates are available. 4 AND gates are there. Here 2 inverters are there, which are also known as a NOT gate, and this is an OR gate is available. Okay. Now I want an output of D0. My output should come D0. So I will be providing an input of 0 0 to the select line A and B. So the first, let's see the first line of the our truth table. When my input is 0 0 for A and B, my first AND gate will be get selected. Now how? Let's see. The value is here 0. Here is also 0. This 0 will pass through an inverter. It will get converted into 1. Same here for B, 0 will be getting passed here and it will be getting converted to 1. So now this value, see this wire, this connection. It is getting connected to the first AND gate. A is getting and B is getting. A bar, it is A bar and B bar. A bar is getting connected to the first AND gate. B bar is getting to the connected to first AND gate with the value 1 1. As we know the truth table of the AND gate, let's see here. Whenever the inputs are high to AND gate, the output will be high. In short, we can say that this AND gate will get switched on. Remember in this diagram, whenever one AND gate is on, automatically means whenever one AND gate is getting output 1, all the other will automatically get output 0. I will be explaining you. Let's see. As I have told you, both the inputs are 1 1. So here output will be 1. Now whatever the value will be there in D0, it will get passed through first NAND gate. If it is 1 0, whatever it will be, so that value will be getting passed through first AND gate. Automatically these values will be 0, and this first value D0 will be here. In this first line D0 will be there, and all the other 3 lines will be 0, will be value will be there. So Y will be getting D0. Now how others are getting 0? Now let's see that. Let's see the first example only. When A and B are 0 0. When A and B are 0, here inverted value is 1 1. Now first, when both the inputs are 1, the first AND gate is on. It is getting 1. Now for the second value, B was 0. So see this. See my cursor. Okay. Second AND gate is getting 0 value. Where is the cursor, man? So first, second AND gate is getting 0 value. If any of the input is 0, automatically the output is 0. Okay. Now going towards the third AND gate. Both the inputs were 0. See this. My 0 is coming here. See the cursor? It's coming here and it's going to the third AND gate. 0 is passing to third AND gate. Automatically, if any value, any input to the AND gate is 0, output will be becoming 0. Okay. Now in the same way, that same 0 has been passed to the third AND gate. So my intention, so I want to say that whenever particular AND gate is switched on, automatically all other AND gates will getting switched off. So that particular, whichever the AND gate is switched on, that AND gate will pass the particular value. So when the in the first truth table we can see the first AND gate is getting on, because of that it is passing, we are getting D0. Now let's take an example of this last one, 1 1. When A and B are 1, A is getting 1 and it is getting passed to here, and gate, fourth and gate is getting first input as a 1, second input is, as I have said here, both are 1, so B is also 1. So the first and 4 is getting, and gate number 4 is also getting one value for B. So both are high, both are getting one value, so automatically here output will be 1. So output will be whatever the D3 value will be there, it will be you will get here D3 value you will be getting, and that D3 value will be passed to this OR gate, and the in the output we will be getting D3 value. Okay, so here is also an equation for the 4 is to 1 mux output equation. When we can see, when both the inputs are inverted, it is 0 0, D0 is when getting selected. When A is 0 and B is 1, D1 is getting selected. When A is 1, B is 0, D2 will be getting selected. When A and B both are 1, D3 will be getting selected. Now let's see 2 is to 1 multiplexer and 4 is to 1 multiplexer block diagram. So block diagram is simple. Uh, just you have to create a box. It's 2 is to 1, so two inputs will be there. One select line will be there, as I have explained you further by the formula 2 the power m is equal to n. As you can see in my this slide here, 2 the power m is equal to n. So if two inputs are there, one select line will be coming and one output is there. When the select line is 0, the output first input will be the output. When select line is 1, the second input will be as your output. This is the circuit diagram for the 2 is to 1 multiplexer. This is the block diagram of 4 is to 1 multiplexer, where the 4 inputs are there, 2 select lines or control lines are there, and this is the one output. I hope you people have got this, and please, if you have any kind of a doubt, you can mail me on this my email ID. Thank you for paying attention. Please subscribe my channel and like it. Thank you.